Okay, for some exercises. What you're doing in each of these games on all the problems is you need what's called solving the matrix. And what that means is what you're doing is trying the most optimal strategy for the pitcher, and then the most optimal strategy for the batter, what he can expect, and then what's called the value of the game. So number 6, let's talk about our pitcher first. Remember, the pitcher's trying to determine what the batter's thinking, what he's guessing, so we go by rows there. So 0.3 P plus 0.2 times 1 minus P. This is going to be 0.3 P plus 0.2 minus 0.2 P. Collect like terms and you get 0.1 P plus 0.2. Okay, now we also need to write an expression then for the curveballs, and that right there is your fastballs. Now if the batter guesses curve, the pitcher's got to weigh his percentages. So 0.1 P plus 0.4 times 1 minus P. Okay, so that's 0.1 P plus 0.4 minus 0.4 P. So that's going to be negative 0.3 P plus 0.4. Now to find the P value, we set the expressions equal to one another. So 0.1 P plus 0.2, that's for the fastballs, equals my curveballs, so negative 0.3 P plus 0.4. Add your P's together, so plus 0.3 P plus 0.3 P, and then minus 0.2 minus 0.2. So it's going to be 0.4 P and then 0.2. So I divide by 0.4, and that's going to be half. So P equals 1/2. So what the pitcher should do is he should throw 1/2 fastballs and the other half curveballs. Just write that as your answer. Okay, now let's find the batter's most optimal strategy. Okay, now the batter's trying to expect the pitcher, what he's going to do. Okay, so we go by columns. So 0.3 times P plus 0.1 and then 1 minus P. Now simplify that. 0.3 P plus 0.1 minus 0.1 P. So that's going to be 0.2 P plus 0.1. That's for fastballs. Now we need to do the curveball column. So 0.2 P plus 0.4, 1 minus P. So 0.2 P plus 0.4 minus 0.4 P. Okay, so that's going to be negative 0.2 P plus 0.4. Now set those equal to each other, this and this. So to solve for P, 0.2 P plus 0.1, and then negative 0.2 P plus 0.4. So plus 0.2 P plus 0.2 P minus 0.1 minus 0.1. So it's going to give us 0.4 P equals 0.3. So when I divide, that's going to be 3/4. Okay. So the batter should expect the pitcher to throw 3/4 of the time fastballs, 1/4 of the time curveballs. Okay. Again, the pitcher should throw, if you're from the pitcher standpoint, he should mix it up half and half. But the batter, he should expect 3/4 fastballs, 1/4 curveballs. Now, here's how you decide the game value. This is another answer that they want. All you do is take that half for the row, the one we did the rows in, okay? The one we did the rows. Take 1/2, okay? Insert it into one of your expressions, probably fastballs, because 1/2 is fastballs, so insert it into the fastball expression. You only need to do this one time, So 0.1 times 1/2 plus 0.2. 0.25 is the game value. Okay. What that means is 25% of the time the pitcher's going to be successful. The batter's going to be successful 25% of the time. Okay? The batter's going to hit. If each guy follows his optimal strategy, okay, pitcher does that, batter does that, and they face off a bunch of times, the batter's going to get a hit 25% of the time. So 0.25. That's what the game value. So actually the pitcher's coming out ahead because obviously he's going to get him out more times than he gets a hit. Okay, number 7. Fastball and knuckleball, it's the same thing. Okay, so let's look at our pitcher. What should he throw? How should he mix up his pitches? Okay, remember, he's determining what the batter's thinking. So when you're at, I know it kind of sounds weird because the pitcher's lined up by columns, but the pitcher's trying to guess what the batter's going to expect. So 0.5p plus 0.2 for the knuckleball, and then 1 minus p. So 0.5p plus 0.2 minus 0.2p. So it's going to be 0.3p plus 0.2. And that's for our batter's guessing fastball. Okay, now the knuckleball. 0.2p plus 0.3 and then 1 minus p. So it's going to be 0.2p plus 0.3 minus 0.3p. That's going to give me negative 0.1p plus 0.3. Now set those equal to each other. So 0.3p plus 0.2 equals negative 0.1p plus 0.3. Okay, so plus 0.1p plus 0.1p minus 0.2 minus 0.2. So it's going to be 0.4p, 0.1. So divide by 0.4, that's 1/4. Okay, so the pitcher, what he should do is throw 1/4 fastballs and 3/4 knucklers. Okay, and that's your first answer. You got to write that. Okay, now let's look at what the batter, what he should be thinking, what he should be expecting. Now the batter is deciding what the pitcher is going to throw him. Okay, so we go by column. So 0.5p plus 0.2 and then 1 minus p. Now since that's the same as we started with up here, we know that that's 0.3p plus 0.2. Okay, now for the knuckleball, 0.2 times p plus 0.3 and then 1 minus p. And that's actually the same thing too. Okay, so we know what that ends up as because from the last part. So if you notice, gee, this is the same, you already know it, okay? And you also know that the answer comes out 1/4. So he should also be thinking the same thing, the batter, so 1/4 and 3/4. Okay, sometimes they can be identical. Now what I do is I take 1/4 and just simply insert it into the simplified expression for my fastballs. The first one I got, the row one, okay? So that's 0.3 times 1/4 plus 0.2, okay? 0.275, okay? So the game value equals 0.275. That means if the pitcher does this and the batter expects this, then if they keep facing off, the batter's going to bat 275, okay? All right, number 8. Number 8's kind of a weird one. Blooper ball and knuckleball. Okay, so here's the pitcher strategy. Okay, what's the batter thinking? He's thinking, well, when he guesses blooper and the pitcher throws a blooper, the batter gets a hit 40% of the time, and that's times P. And then when he throws a knuckle, but the batter guesses blooper, he's only going to get a hit 20% of the time. That's 1 minus P. Okay, so simplify that. So 0.4 P plus 0.2 minus 0.2 P. Combine like terms, so 0.2 P plus 0.2. Now that's simplified. Okay, now let's talk about still on the pitcher, how about his knuckleballers when the batter's expecting knuckleball? So 0.25 P plus 0.25 times 1 minus P. 0.25 P plus 0.25 minus 0.25 P. Well, the thing is, those end up being 0, so it's just 0.25. That's simplified. Okay, so set them equal to each other. So 0.2 P plus 0.2, 0.25. All you got to do is move the 0.2 over. So I have 0.2 P, and this is going to be 0.05. Now that's not as easy to reduce. So what you want to do is make sure they have the same amount of decimal places. So add a 0 here. So if we have 5 over 20, that reduces to 1/4. Okay, so what the pitcher should do is 1/4 and 3/4. He should throw 1/4 blooper balls and then 3/4 knuckleballs. Okay, now let's look at what the batter should expect to hit the highest average possible. Okay, so the batter, now we're going by columns, so 0.4 P plus 0.25, 1 minus P. So 0.4 P plus 0.25 minus 0.25 P. So subtract that, you're going to get 0.15 P plus 0.25. There's a batter. Okay, now we also have to do the knuckleballs, the column for that. So 0.2 P plus 0.25, 1 minus P. Okay, so 0.2 P plus 0.25 minus 0.25 P. So that's going to be negative 0.05 P plus 0.25. Okay, now set them equal. 0.15 P plus 0.25. Negative 0.05 P plus 0.25. Okay, now if I add the P's over here, collect like terms, and I move the 0.25, what we have is 0.2 P equals 0. So when I divide, it doesn't matter what that is. That's 0. P value is 0 then. So what that means is the batter should expect 0 blooper balls, and then 100% of the time, which is 1, he should expect knucklers, okay? That's how you're going to hit the highest average. Just always look for the knuckler, okay? Don't ever worry about the blooper pitch. Okay, now to find the game's value, plug your 1/4 in for P there. In the first expression, 0.2, 1/4 plus 0.2, 0.25. So the game value equals 0.25. So what that means is if the pitcher throws 1/4 blooper balls, 1/4 of his pitches are bloopers, 3/4 of them are knucklers, and then the batter's thinking, okay, I'm never going to guess blooper ball. I'm always going to guess knuckleball. The batter's going to hit 250. That's the value of the game. Okay, then the last one is number 10. When it's third down and short yards, you go for a first down in football. The quarterback can decide to run or pass it. Similar, and there's Brett Favre right there, man. Similar, the other team can commit itself to defend more heavily against a run or a pass. And here's the 2x2 matrix, okay? So the offense dictates what they're going to run, just like the kind of the pitcher does right there, okay? So let's look at since we're doing pitcher first up there, let's do defense right here, okay? Let's do the defense. So the most optimal strategy for the defense, okay? So they're guessing what the offense is going to run, okay? So 0.5 P plus 0.8, 1 minus P. 0.5 P plus 0.8 minus 0.8 P. So this can be negative 0.3 P plus 0.8. That's simplified. Okay, now the offense. Okay, pass. So 0.7 P plus 0.2, 1 minus P. Okay. What this means is if the defense guesses run and the offense runs it, it's going to be a stop. They'll get it 50% of the time. Defense guesses run and they pass it, the offense picks up the first down 70%. Defense guesses pass and offense runs, the offense picks up the first down 80% of the time. Pass, they guess pass, they pick it up 0.2% of the time. So let's continue on here. So 0.7P plus 0.2 minus 0.2P. So it's going to be 0.5P plus 0.2. Now set the two things equal. Negative 0.3P plus 0.8. 0.5P plus 0.2. So you minus 0.5P and then minus 0.8 minus 0.8. Okay, so that ends up being negative 0.8P, and that's negative 0.6, and then divide, and P is going to equal 3/4 because that's what 6/8. Okay, so 3/4 and 1/4. So what the defense should do, and remember the first one is run, so they should guess that it's going to be a run 3/4 of the time and a pass 1/4 of the time on third and short. Third and short, you'd probably more likely to run it too, like 3rd and 1. Remember, 3rd and short. Okay, so now let's look at our offense. Remember, the offense is guessing what the defense is thinking. Okay. So now we go by columns. So 0.5P plus 0.7, 1 minus P. 0.5P plus 0.7 minus 0.7P. So this can be negative 0.2P plus 0.7. Now let's talk about the other columns. So 0.8P plus 0.2 and then 1 minus P. So 0.8P plus 0.2 minus 0.2P. So this can be 0.6P plus 0.2. Okay. Now your equation, I should say. Set them equal. So minus 0.6P, minus 0.6P, and then minus 0.7, minus 0.7. So you get negative 0.8P and then negative 0.5. So I divide, that's going to be 5/8. So 5/8 and then 3/8 would round that out to a whole. 1 whole minus 5/8. So on third and short, if I'm the defensive coordinator, I'm guessing run 3/4 of the time and then pass. That's a pass, should say pass, 1/4 of the time. Okay, if I'm offensive coordinator, when I'm statistically, I want to run it 5/8 of the time, pass it 3/8. Now to find the value of the game, you take your 3/4, okay, right here, and just plug that into your first simplified expression. That gives you the game value. 0.3, so negative 0.3, and then 3/4 plus 0.8. 0.575, okay? So the game value so that means 57.5% of the time, if they do this and they do this, the offense is going to pick up that first down 57% of the time. So it's actually a better deal for the offense. Okay, statistics show. Okay, that's really all I have to say on that chapter. I hope it has been informative, and let me know if there's any problems.